And welcome everybody once again to the Daily Space Weather. I'm your host Dan, aka smAsho Mash, and more interesting stuff to cover once again today. Please don't forget to press like and subscribe, share with your friends and foes on social media, etc. Share with your local astronomy club. Share with your science noobs and your science pros. Today we'll be talking about the sun as we do every day on the Daily Space Weather. Also the Cygnus X complex filament. And also some weather stuff. So first we've got a composite view here of the sun. It's three different wavelengths, all in one, 335, 193, and 94 angstroms. New sunspot group has risen, and if it continues to show ombre, it'll be sunspot 2794. We've got two groups in the southeast. We covered some coronal mass ejections yesterday, and the coronal mass ejection watch continues. We'll tell you why momentarily. Something we do regularly here at the Smash News Network. We do this thing called solar forecasting. Why? Because nobody else seems to be able to do it. So here we are. I didn't butt in line. People requested that I report to the head of the line. So cheers. The 10.7 centimeter radio flux, currently at 83 solar flux units. There's the 1 year chart of that. And the radio flux is the second most important measurement of solar activity. So here you can see the sunspot number progression, as well as the radio flux progression. And for you new viewers, the radio flux is a measurement of the radio output of the outer solar corona. Here's another composite view of the local yellow dwarf. And if you've got comments directly for the sun, leave them in the video, and perhaps we'll read them in tomorrow's Daily Space Weather. If you think the sun's conscious, let us know. Ancient civilizations almost universally believed that the sun was conscious. And there are some similarities to the way the sun operates and the way a brain operates, believe it or not. I won't comment on today's video. We'll have to save that for a cosmology segment. By the way, this one is the 171 angstroms view and the colorized magnetogram. So let's take a quick look at the fields here. Here's 131 angstroms. Make sure we have the latest. There you go. There are the fields. And we saw some tiny ombre associated with this active region right here. And again, if it stays active, it will become sunspot 2794. And there's the fade between 335 and 304 angstroms. And let's take a look at what's going on from the perspective of stereo A, which is located out here at Lagrange point 5. Here's me vanishing, and there's the view from stereo A's coronagraph. Now, for you new viewers, the Earth would be out in this direction. And we do see this plume of plasma out here, which still has a capability to eject. You don't need a solar flare for that to happen. And I would also note the coronal mass ejection we see on the far side of the sun. And you can also see Venus swinging in behind the coronagraph. And we'll also give you a quick view here of the LASCO C2 and LASCO C3, part of the SOHO suite of instruments. Nothing exciting going on there. And we've got some more HelioViewer movies for you. This is actually Mercury, you see there on the right of the screen. And you can see yesterday's coronal mass ejection, not Earth-facing. If you didn't watch yesterday's video, you might not know yet. Here's another HelioViewer movie of the sun in 171 angstroms. Significant coronal hole down in this area, and that filament we showed you on stereo A is located around this area. And let's get on to some more views here. And just give me a moment, we are streaming live. And I would invite all of our viewers to make sure you join us at the moment of the solstice, because we will be streaming live at the moment of the solstice. It'll be a YouTube exclusive. And the time of the solstice for planet Earth occurs on December 21st at 5:02 and 20 seconds. That's 5:02 a.m. and 20 seconds Eastern Standard Time. And I'm in the Lehigh Valley. We've got the same time as New York City, so you can use New York time. Today's Smash Lights segment will have to be postponed until later time. This afternoon we'll actually do a meteorology video. Thanks to all of our new subscribers. Please take a moment to press like and subscribe if you haven't done so yet. Don't worry, we'll wait. And the place is going to continue to burn to the ground until you press like and subscribe. So if you enjoy the content, don't make me have to keep putting fires out. Again, tell your friends and foes, science noobs and science pros, about the channel. We may have something for everyone, or you may just think I'm a jerk. Either way, it's fine. Did you watch yesterday's video about the coronal mass ejections? Was it dangerous? Well, you have to find out by watching the video. Here's a clip.
The Smash News Network. Again, if there's anything in particular you'd like us to talk about, let us know in the chat. We'll get back to that before we close the video out.
We also are all over social media, such as on BitChute. Don't forget to check out our own website. You can get to it at smashomash.org or smashomash.com. We own both domains. Interact with us on social media. You can find all of our social media there, as well as our smAsho VoIP line, email address, links to our stores. And if you check out the smAsho store or the Smash store, make sure you enter the promo code smAsho to save 10% on all orders through Christmas. Thanks to everybody who's been ordering merch. We greatly appreciate that. Give Smash staff a raise by ordering some merch. And let's get on to thank our Twitch viewers. We are currently streaming live. It's twitch.tv/smashomash. And we're hoping that, we're able to put out all fires, as we are appreciative of facts and a little bit harsh on hacks. So we're going to talk cosmology today. And we don't always talk cosmology, but sometimes we do. And today's a great day for it. It's a great day to lock yourself inside and talk about cosmology. So let's talk about the X complex. Now, one of the objects in the X complex is Cygnus X1. What's so great about Cygnus X1? Well, Cygnus is the most interesting portion of the Milky Way galaxy. It contains the most luminous object visible from Earth, which is not Cygnus X1. Cygnus X1 is the first object widely believed to be a, quote, black hole, end quote. So Stephen Hawking and Carl Sagan famously had a bet about Cygnus X1. And I don't know who bet on what, but they bet in the late 70s, early 80s, whether or not Cygnus X1 was indeed a black hole. So anyway, there's a view of it on Aladdin Light. And let's take a look at it in X-ray here on the Chandra. And there's an X-ray image of Cygnus X1. Great view of that, actually. It looks like you can see a jet there. They've only got half of it. This blue area, this is an artifact. This blue thing here, that's an artifact. But there is some evidence that there may be a jet around here somewhere. Perhaps. And let's see what it looks like on the 2 mass, if it shows up at all. And there's Cygnus X1 on the 2 mass. One of the better ways to view those. And you can link to all of this stuff at the Neil Gorell's Burst Alert Telescope. Just hit Control F and type Sig X1. And you'll find that it's entry number 896. So what's going on? Well, here's where it's located, by the way. This is the X complex. So the galactic core is right around this area somewhere. That's around where Sagittarius A star is located. And this is the X complex in the green circle over here. And it's an interesting place to say the least. It's full of blue supergiant stars. It also contains Cygnus X3, otherwise known as Deneb. Here's a composite image of the X complex. And it's a very interesting place to study. There are cosmic rays emanating from the X complex and lots of interesting objects. So yeah, the Cygnus X complex. What's up with it? Well, there's a Filament study just released in, which is picked up by phys.org. So we've got 2,600 stars in there, up to a mass of about 1 million suns. So about 1 million, 10 to the 5th solar masses can be found in the X complex. It's full of gas and filaments and X-ray emissions and proton emissions and all kinds of interesting stuff. So here's this filament. It's known as DR21 and DR22. Turns out there are actually 2 filaments in there. And I'm just going to let the article scroll. First I'm going to vanish off the screen. So this particular, the edge of this cloud is believed to be about 4,600 light years, 4,600 light years away. And DR21SF is the main filament that we're talking about here. Believed to have about 1,048 solar masses. And it's actually, it's got some accelerating gas outflow going in it. And that's the main aspect of what we're talking about here. Could have something to do with, well, I won't get into it too in depth here, but have yourself a read if you like. It's on phys.org in the Astronomy and Space section. Study explores a unique filament of the of the Cygnus X complex. Yes. And that data was obtained using the Shanghai 65-meter Tianma radio telescope. Salute to those Chinese astronomers. And there ends today's cosmology segment. Let me just take a moment to check the life of the stream. And we are good to go. Let's get back to some data about the weather occurring in space. Space, a frontier. These are the voyages of the starship of the YouTube channel smAsho. Our continuing mission to forecast in ways nobody else has the ability. To seek out new life and new smart people. To boldly forecast what no one else on Earth is able. Let's look at the real-time solar wind. It's recently dropped quite a bit, from about 14 protons per cubic centimeter all the way down to about 2. Off the lows right now at about 5 protons per cubic centimeter. Otherwise not too interesting here, as the BTBZ has converged largely on the 0 line. Phi angle around the 360 mark. Solar wind speed very low, 285 kilometers per second. The KP index, a measurement of global geomagnetism, is at 1 for the past 12 hours. Here's the magnetohydrodynamic pressure in geospace. Looking at 4 hours of geospace magnetosphere movies here. We show it daily. And this does provide somewhat of a snapshot. You can take a guess of what the solar wind might be like just by looking at this pane. It's courtesy University of Michigan, and it's based on the space weather modeling framework. Next, we'll look at ground perturbations. We don't see a whole lot of induced magnetism, as we see a very low solar wind speed. And we'll just let that play through. That's 4 hours of data as well. Let's advance that to where it was before it refreshed. Nothing exciting happening there, although we are living through a polar excursion. So welcome to the polar excursion. Welcome to the Neo-Renaissance. And let's continue on with the daily space weather. Next, we'll look at the proton flux, which is a very important factor here, as it is related to things like earthquake forecasting. So there's a 3-day proton flux, totally flatline there. Nothing to write home about. And as far as solar flaring activity, we haven't seen too much of it here. a B-class flare happened. The last flare we saw was this B-class solar flare, which happened around, please, it happened around 2140 Universal Time yesterday. If you want to make yourself a movie of that flare to see where it came from, knock yourself out. Next, looking at a star chart. And I've drawn in the ecliptic here and faced my star chart to the south. I use in-the-sky.org. Not an official partner of the Daily Space Weather videos, but if you're watching, drop me a line. We'll be more than happy to make a video just about your website, because we like it. Anyway, there's the ecliptic. The sun's going to go through Virgo and Leo and Gemini, and then when it gets to Taurus, people are going to be very, very scared and spooked because, oh my God, Uranus is in Taurus or something, which is very scary because reasons. Next, looking at theplanetstoday.com. It's where I go for my solar system charts. And there you have it. And there you have where things will be in a week. Next, the GOES magnetometer, before we get into other magnetic data. And we do see an arc jet moment there. An indication that the spacecraft has had to orient itself, or perhaps change altitude a little bit. Nothing too exciting happening in the GOES magnetometer. Let's check and see the polarity of the current sheet. Now the data here is 8 hours and 30 minutes old. 8 hours and 58 minutes old. That gives you an idea of how long it took me to do show prep. It took me 20 minutes to get from that tab back to that tab, folks. In any case, it looks like the South Pole current sheet has evaporated in the earthly region, and we won't spend too much time on this as the data is quite old. There's a line of sight coronal hole field plot. North Pole shown in green, South Pole shown in red. Here's one that shows the Z fields as well, the solar polar fields, and the solar B field, which is indeed the one in which you live, shown in blue. And next we'll look at a field plot of the solar atmosphere known as the corona. It's the coronal field plot. And we show that one daily too. If you want to see what's happening tomorrow with it, make sure you view tomorrow's Daily Space Weather video. And stop viewing me as it's time for me to vanish once again. Next, we'll talk about electrons. And we'll bring up the satellite's community dashboard to show no charging hazards right now. Here's the one-year chart of the electron flux. And we're expecting a downtick here in electron flux. Going to see some weak Van Allen belts in the next couple of days. And I would concur with this forecast as solar activity has been weak over the past week. There's the 3-day chart of the electron flux, and we're expecting that to be even lower than it was. Here's a visualization of the total air column from the thermosphere all the way down to your handset, essentially from where your GPS satellite's located down to where you're located. And we do typically see more anomalies when we see very low levels of electron flux. I won't get into the physics, but anyway, there's the data, complete with timestamps. And here's just a diagram of the Van Allen belts. You can see the inner and outer Van Allen belts, the Van Allen probes, the altitude of a GPS satellite, the altitude of the International Space Station. And these are all in miles. Keep in mind, these are in kilometers. This is giving you an idea of, for instance, the troposphere versus the stratosphere, and so on. And the GOES 16 is measuring things at the F layer, shown there on the right, the red F, that's the F ionosphere layer. It also does show you the way electromagnetic radiation from the sun penetrates, which layers sort of filter and adsorb which aspects of solar radiation. That's those bars in the center there. For instance, infrared light makes it all the way down to your face, which is why the sun feels warm. Next, looking at just the ionosphere layer. And this is 24 hours of data, courtesy Bureau of Meteorology, Government of Australia. And it's looking a little anomalous here in the southern hemisphere, to be honest, which I always am, by the way. I don't know why I said to be honest. That's a ridiculous thing for me to say. Because if you think I've been deceitful, you're just wrong. Anyway, here's the latest image. That one coming in at 8:30 Universal Time. Again, quite charged up there in the southern hemisphere. Something probably typical of low electron flux. Next, looking at volcanoes. We'd like to know what's erupting, since a large volcanic eruption could essentially end civilization as we know it. Kluchovskoy, whether or not it's erupting, we're not able to tell from satellite imagery. And it's in a very desolate location, the Kamchatka Peninsula, someplace I would like to go on vacation. As I like desolate locations, I think it's fun and challenging and exhilarating and exciting. Next, looking at Sakurajima, flight level 7070 there. It's a 7,000 foot ash plume. Popocatépetl exploding, which is, by the way, on my volcano bucket list. If Mexico can get their you-know-what together, I would love to go visit Popocatépetl. It's producing a 19,000 foot ash plume right now. Fuego exploding as well, 16,000 foot ash plume there. Sangay exploding, 20,000 foot ash plume there. Revenador, 15,000 foot ash plume as it also explodes. And Sabancaya is reminding us with a 27,000 foot plume of ash not to attempt a back handspring over the caldera as it is exploding. And that could be unhealthful for our viewers. Next, looking at earthquakes over the past 24. Nothing over a 6 magnitude as we reported yesterday. Yesterday we did report a 6+ magnitude quake. It happened in western South America. So we see some deep quakes here to start the list off here. There's a 4.3 at 159 kilometers depth. That's 159 kilometers below the surface of the Band A Sea. That one happened at 10:49 Universal Time yesterday. And we're just going to let this scroll up the list here. A nice smooth scroll for your viewing pleasure. And here's another deep quake. It's only a 3.7 magnitude. And it is near the Dominican Republic, the island of Hispaniola. One of the larger quakes of the past 24 was also a deep one. And I stand corrected, there was a 6+ magnitude in the Philippines. This deep quake happened at Vanuatu at 22:43 Universal Time. A 5.0 magnitude at 124 kilometers. And there's the largest quake of the past 24, actually a 6.1 at the Philippines. Somehow I missed it. Let's check the location. And that one happening south of Davao City. And we'll zoom out to show you the location of that. Largest quake of the past 24, I think. Certainly looks like it. Another deep quake strikes Chile. A 4.5 magnitude at 122 kilometers. Decent sized quake in the Aleutian Islands at a 5.3 magnitude. And let's move on to look at the jet streams. There are the jet streams of the Western world. Next, the jet streams of the Eastern world. He's showing the whole world of jet streams. Yeah, the whole world of jet streams. We saw some extreme lightning on the western coast of Australia. Is it going to fill it in? Must have been too long ago. But there was a bunch of lightning when I did show prep. And we've got some lightning in the U.S. south of New Orleans. Hey, Nolans. Also Mobile. go out and look to your south, you may see some interesting stuff going on above those thunderheads out in the Gulf. When I hear thunder, oh, there you go. You can see all that lightning on the west coast of Australia there. Quite a bit of lightning strikes. And actually still going on now. And lightningmaps.org will actually show you thunder propagation. Yes, you can forecast thunder. Here's the GO16 lightning mapper. And you can see all that heavy lightning there in the Gulf of Mexico. Stay below decks if you're out shrimping with Forrest Gump. And here's a US Doppler radar map. And again, we're going to do a meteorology video early this afternoon. So if you're in the mid-Atlantic states, and really any place from New England, that whole area, we're going to forecast the nor'easter today. So we'll get out of my comfort zone once again and do a meteorology video, not to step on the toes of our pals who are into meteorology. So here's the current GFS model for the impending snowpocalypse of Pennsylvania. The whole state's going to be blanketed. And we've actually recently had a reduction. We were expecting more like 2 feet, and now we're expecting more like 1 foot. And again, for you new viewers, I'm located right around there in Lehigh Valley, Pennsylvania, 1 county west of the easternmost county there, Lehigh County. The easternmost county is Northampton. Never mind. That's where we're located. And that is the forecast through tomorrow, Thursday, December 17th at 1800 Universal Time. Next, looking at the pressure cells here. And this low pressure that is right over Virginia Beach right now is what's causing that nor'easter. So we'll advance this to tomorrow at 1800. And by then it'll be off the coast of Maine. And again, we don't always do meteorology videos, but today we'll actually do one. Next, we're going to show you the cloud layer. And there's what's going on in the clouds. That moisture is coming from the west. And when it meets up with that low pressure cell, well, it's going to make some considerable precipitation. So, and if you're in eastern Pennsylvania, things are going to get hairy at about 3 o'clock this afternoon. Please have all your affairs in order by then, as you may be inundated. So again, there's the cloud layer. Once again, we see a ton of low clouds here. Look at all the low clouds, as well as over the Gulf. Indiana getting heavy snow, as well as southern Illinois already. And let's zoom into Indiana here since you're getting hit. Leave us a comment if you're from the area. We're always interested in where our viewers are located. And there's your custom zoom in. And this little spike of dry mass of air is helping to push that system through. Doesn't look like it'll stagnate very much. Although that is breaking down a little bit. Great view there of the water vapor map. And we've got some bonus features, folks. Make sure you don't go anywhere, since we're going to show you the colorized magnetogram, the rest of our HelioViewer movies, and the intensitygram to show you the current sunspot situation. Here's the colorized magnetogram. And this area here is looking more like a sunspot and not less. This is sunspot 2793. And this is sunspot 2792, which has degraded since yesterday. We still do have a significant possibility of coronal mass ejections. And some C-class solar flares could be kicking off. You can see sunspot 2793 actually grew. Sunspot 2792 shrunk. Although they are both still beta class, as we've got a South Pole and a North Pole umbra on both of those. And this area here, I do see umbrae, and I'll forecast that that will be a sunspot. And let's get to the rest of our helioviewer movies here, starting with the 304 angstroms full disk view. There's that. And there is some filamentary activity down here too. You can see right there. Right here, you can see a filamentary eruption there. And we'll view that more closely in a different wavelength or two. Great view of that filament. We may have to do another video later today about just that too. First, the northern hemisphere in 171 angstroms. Great view of the North Polar region there. Here it is in 94 angstroms as well. And let's check out where the main activity is happening in the south. And there you can see that filament. That did not turn into a coronal mass ejection. That splashed back down onto the chromosphere. Great view of that in 94 angstroms. Here's the same thing in 171 angstroms. And you can see some transverse waves coming out of that, an indication that the sun has a real surface, not an illusory surface, as mainstream astronomy may purport. So anyway, thanks for tuning in, folks. We are out. Remember to stare at the sun, don't drink, and if you do, don't drive. Don't let the government drive you to drink, and if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Thanks again for tuning in. May that solar wind be at your back.